All right, my math homies, let's get this show on the road. We're going to dive into the unit circle today. So you definitely want to have your notes printed as well as your blank unit circle, because you can start filling that in as we start talking about how we find all the different values. But you'll definitely need to recreate that unit circle very large and nice and neat in your notes. So the big question is, how do we create a unit circle, and then going forward, how is it we're going to use it? But right now, we're not really going to use it for more than very basic calculations, but you'll want to hang on to that unit circle because we'll be using it as we continue through the chapter. So let me explain what a unit circle actually is. It's a circle created by drawing triangles. And the key is every triangle that we draw has the same length of a hypotenuse, and we'll just call it 1 unit. It can be 1 inch, it could be 1 mile, it just depends on how we want to how large we want to create the unit circle, but every hypotenuse of every triangle that we draw will have the same length of 1 unit, and each of those triangles is drawn around an origin. And so once you're done drawing every single triangle, you'll see that a little unit circle is created around the origin. So I'm going to show you a graphic in just a minute on what that looks like. But before we get there, let me just show you one example. When I draw a right triangle with the hypotenuse of 1 in the coordinate axis, the angle here, we'll call it theta. Now last week, we learned how to draw these angles going all the way around a coordinate axis, right? So this could be like a 30-degree angle. And we learned about reference angles and coterminal angles. So if you haven't done that lesson, you need to go back and review week 2 material. So when we start looking at this particular triangle, if I want to get to this coordinate right here, which is at the end of the hypotenuse, I know that I would have to go right so many units and up so many units to get there, right? So xy would be my coordinate. Well, if we look at this in terms of a right triangle and SOHCAHTOA, I know that cosine of that angle, cosine of theta, equals adjacent over hypotenuse, which is x over 1. Well, anytime you divide by 1, it just goes away, right? X divided by 1 is x. So that means that cosine of theta is equal to x. So what that means is the coordinate x can also be called cosine theta. And that's super helpful because now I know that whatever this x coordinate is, that's the same value of the cosine of that angle. The same is true for sine. So when we look for the sine of this angle, it would be opposite over hypotenuse, which is y over 1. And that means we can divide by 1, nothing changes. And so the y coordinate is the same as the sine of theta. So this is how it's going to be used. We're going to take a look at, let's say, the unit circle at possibly, we can use, let's say, the angle 45 degrees. And the coordinate tells us what the cosine and sine value are of 45 degrees. It's actually really slick. It's kind of like having tables of values before we had calculators, right? And so you could just look at the table in order to calculate something. The unit circle is like a little abacus or a table in a sense. And I know you're probably going, well, what's the point? We have calculators. There are times where you're not going to have your calculator, and it's just an interesting concept, and then we'll be able to use that unit circle going forward. So check out this little graphic, and then we will come back to our notes. All right, so as we continue to draw triangles, you could see, as you continue to draw them around, you begin to create that circle, right? And so every coordinate on the circle has a cosine and a sine value. And so that's gonna be extremely convenient for us. But before we do that, I need us to have a really good sense of positive and negative quadrants, okay? And then we'll get into actually creating a unit circle. So what I want you guys to remember is that we have quadrants 1, 2, 3, 4, and pretty much every textbook uses the same quadrant numbering system. And we start with quadrant 1 is our positive quadrant, meaning our first first quadrant is the upper right. That means that both your x and your y coordinate are always positive. And then we're gonna move counterclockwise. So quadrant 2 has a negative x coordinate and a positive y coordinate. Well, if we know that these coordinates are also representing cosine and sine, that means that my cosine of whatever angle is in this quadrant will be negative, and my sine of that angle will be positive. Then we keep going counterclockwise. So we have quadrant 3. That is where both x and y are negative, which means both cosine and sine will be negative. And then finally, quadrant 4, that's where your x coordinate is positive and your y coordinate is negative. Okay, so I want us to use those facts with some examples here. So what will be the sign, meaning the positive or negative sign, so S-I-G-N, not the cosine and sine. So what will be the sign of cosine and sine for the following angles? So for instance, 60 degrees. Well, where does 60 degrees fall in which quadrant, right? So remember, when we would draw angles in a quadrant, we always start, our initial side is the positive x-axis, and then we open it up to 60 degrees, right? And then where does your terminal side land? That tells you what quadrant you're in. Well, I know that if I were to open up all the way to here, that would be 90 degrees. So that means I've gone too far. So 60 degrees must be in quadrant 1, and that means both cosine and sine are positive. So you can say cosine is positive, sine is positive. That's because we are in quadrant 1. What about 225 degrees? Well, you have to figure out where does that land. So if you were to open up to here, that's 90. If we go all the way over to a straight angle, that's 180. And then if you go another 90 degrees, that's 270, right? Think of it in terms of 90-degree segment or sections. So at 270, I've gone too far. So that means 225 is between this 180 degrees and 270. And then we'll write 90 up here. So that means 225 is in quadrant 3. So that tells me that cosine is negative and sine is also negative. So that's how we figure this out. Cosine negative, sine negative. Okay, and now I'm gonna throw a radian at you because remember we did cover radians, right? So I wanna know where 5 pi over 6 radians lies. Which quadrant are we in? Now you have two choices. You can convert it to degrees, because I know some of you like to just think in degrees, or you can try and reason this out. So 5 pi over 6. Now pi is just telling us that we're in radians, right? So really we're kind of looking at 5/6 of a pi. Well, pi is 180, right? Pi goes halfway around the circle. So I'm not gonna go quite that far. I'm gonna go 5/6 that distance. So that means that I'm gonna almost get to a complete pi, right? Because 6/6 pi would be 180 degrees. So I'm going almost to 180. So that means I'm in quadrant 2. So what is the sign of cosine and sine in quadrant 2? Well, we know cosine is negative and sine is positive. So cosine is negative, sine is positive. Okay, so that's how we're going to use the facts of the quadrants and positive and negatives to help us get values for sine and cosine. So pause here if you need to write anything down. I'm going to go ahead and switch pages. Okay, so now we're actually going to work on filling in a unit circle. So what you need to be doing, and I purposely printed this pretty tiny here because I do want you to try and do some of the work to fill in your large unit circle. So I'm going to show you how we can do that. And that way you don't have to memorize it. You can always recreate it when you need to. Now you're probably going to memorize after dealing with this. You'll have it memorized pretty easily. But what I'm going to do is I've started with 2 triangles. And I don't want to draw too many to begin with because I don't want this to look too confusing until we've started going through the process together. So the 30-degree angle, the blue angle that you can see here, that right there is a 30, 60, 90-degree triangle, right? And we know that because I purposely drew a right triangle and I purposely chose the 30-degree, which leaves this one to be 60. So we're going to go back to our knowledge of a 30, 60, 90, and we can fill in. We know exactly how far we've gone, right? X, and Y based on the relationship of a 30, 60, 90 degree triangle. So off to the side, I'm going to just draw myself a 30, 60, 90. And I know that the hypotenuse is 1, right? Because this is a unit circle. I purposely chose 1 unit. Now the relationship says the hypotenuse is twice as long as the short side. So that means this is 1/2. And I know the short side has a relationship to the long side, and that is the long side is rad 3 times the short side. So that means rad 3 times 1/2 is rad 3 over 2. So what that tells me is that the long side, the x coordinate, is rad 3 over 2, and the y coordinate is going to be 1/2. And we can figure all that out by knowing our special right triangle relationships, right? So the next triangle I drew also has a hypotenuse of 1. This time I chose for my angle to be 60 degrees. So that means it's the same triangle, it's just now going to be where my 60 degree angle is right in here, and this one up here will be 30. So now the short leg is 1/2, right? So that means in my green triangle, the little short leg, the x coordinate is 1/2. And the y coordinate is rad 3 over 2. Okay, and if you're feeling like, oh my gosh, where is all this information coming from? Let's pause it, slow it down if you need to, rewatch it again. All I've done is I've placed a 30, 60, 90 triangle inside of my coordinate axis. And because I know the lengths of the sides, I can fill in my x and y coordinate. I also know that this represents cosine of 30 degrees. Cosine of 30 degrees is rad 3 over 2 every single time. Sine of 30 degrees is always 1/2 every single time. So that's what's kind of cool here is, and notice I've got my 60 degree angle, and the cosine of 60 is 1/2, which makes sense, right? Because the cosine of 60 should be the same as the sine of 30, right? Because those are co-functions. So all of this is hopefully coming together. I realize it's a little, it's a lot of information to process, right? So what I want to do next is take it into the next quadrant. And I'm going to show you how reference angles are going to help us without having to do all kinds of calculations. So let's say I want to go 150 degrees. So remember, we start on our positive x-axis. There's 90. I'm going to open it up to 150. So 150 is just 30 degrees shy of 180, right? Well, if this whole angle is 150, what is this reference angle here? Well, we know that that's got to be 30, right? And don't we already have the values for 30? The only thing that's going to change over here would be the sine values, right? So if my x coordinate is positive rad 3 over 2 in quadrant 1, what is it going to be in quadrant 2? Well, it's going to be a negative rad 3 over 2. And then 1/2 is the y coordinate. Well, remember, the y coordinate in quadrant 2 is also positive. So that'll be positive 1/2. So you can see that we are going to start filling these values in just by, if we can learn all the values of quadrant 1, we've got it. All we have to do then is do our reflection and change the signs. So it makes it very easy to create an entire unit circle just based on quadrant 1. The one thing I want to cover with you guys that aren't complete triangles would be what happens when we are on the actual coordinate axis. So for instance, when I'm at 0 degrees, my hypotenuse, I really don't have a complete triangle, right? But what is the radius of this circle at 0 degrees? Well, it's 1, isn't it? So what does that make this coordinate here? Well, I know I went out on the x-axis 1 unit, and I haven't moved up or down because I'm on the x-axis. So I'm at 1, 0. That means that cosine of 0 degrees is equal to 1, and sine of 0 degrees is equal to 0. And you can verify that in your calculator right now. What happens when I get up to the 90 degree mark here? Well, I know that, again, the radius of the circle is 1, so that means that I now went from my coordinate is 0, 1. So the cosine of 90 degrees is 0, and the sine of 90 degrees is 1. And again, you can test that in your calculator. Well, what about 180? So again, radius is 1. However, I'm in the quadrant, I'm between quadrant 2 and quadrant 3. I've gone to the left 1 unit, so that's -1, and I haven't gone up or down, so that's 0. So it's -1, 0, right? And then my final is 270. 270 degrees is down here, and I have a 0, -1 coordinate. So hopefully you're starting to see how we're able to create this circle right here with all of these coordinates going around. And now we know instantly that the cosine of 120 degrees is -1/2. And the sine of, let's say, 330 degrees is also -1/2. So it'll help us in understanding sine and cosine for large angle values that we don't have to then, hand calculate or draw triangles. We now have the unit circle to tell us that. So what I'm asking you to do today is print your blank unit circle that I have for you to print in Pearson, and you'll fill in your full-size chart. And I want everything from, I want all the degrees, I want the corresponding radian measures, and you want your X and Y values, as well as making sure the signs are correct. Now you can look this up online if you need some help to fill it in. You can try and blow up this little notes chart that I gave you. Just be careful, some of the negatives aren't quite as obvious. But you need to fill this in and then verify that it's correct by using a resource online. And then you want to put it in your notes because you're going to be able to use it when we answer questions like these down here. So let's practice a little bit and then you'll be set to go on your Pearson assignment. And then just because, so you know this lesson's a little bit longer and a little more detailed, this is all you're doing this week, is you're gonna fill in your chart and you're gonna do the Pearson and make sure you understand these notes. So if that means rewatching the video one more time, that's all I'm asking you to do this week. So let's get some examples of how to do this. So the question will be, find cosine of 2 pi over 3. Well, we know we can go to our unit circle, we can find the radian measure of 2 pi over 3. So we always start at 0 and you can work your way around, right? Otherwise you're gonna feel like you're just endlessly searching. Now, 2/3 means I haven't gone quite a complete 180, a pi rotation, right? So that means 2/3, so this would be 1 whole pi. I haven't quite gone a whole pi because I've only gone 2/3. So it's gotta be somewhere in here, and we can see that it's right there. 2/3 pi, right? Well, we're looking for the cosine value. That means we're looking at the x coordinate, and it's -1/2. And that's all we have to do. So number 2, sine of 11 pi over 6. So 11 pi over 6, well, think about that. 6 can go into 11 almost 2 times, right? So that is almost 2 pi. That's almost all the way around, but not quite. So that means I'm probably gonna be down here in this coordinate. So if you look, yep, sure enough, 11 pi over 6 is right there, right? And we want the sine value of 11 pi over 6, which is -1/2. And it's okay for these to have the same answer, right? Because if you think about it, these are reflections from one quadrant to the next. And then we also know there's a relationship between sine and cosine values, right? We know that they will be equal if these two angles are complementary, meaning they have to add up to 90. Okay, next one, cosine of 180. All right, well, we know 180 degrees is right here on the x-axis. The cosine is the x-coordinate, so that means our answer is -1. Okay, sine of 225. So we got to find 225 degrees. So that's going to be right here. The sine is going to be the y-coordinate, and that's rad 2 over 2. Those values are found from the 45, 45, 90 degree triangle. So I only did the 30, 60 degree triangle up here in our example, but remember we also have the 45, 45, 90 that we can use to help fill in some more values into our unit circle. Okay, the next one, 5 pi over 3. So let's find that in our, again, how many times does 3 go into 5? Well, almost twice, right? So that means I'm actually going to be, I'm over the 180, but I got to figure out where is 5 pi over 3. And you'll see that we're in quadrant 4 for that one. So 5 pi over 3 is right here. We're looking for sine, and that would be the y coordinate, so rad 3 over 2. And then the last one, cosine of 270. So where is 270? Well, that's one of my 90-degree little markers here. So 270, I know cosine is the x coordinate, and so that is 0. Now you can go through and verify all of these in your calculator. What will be different though is when you calculate it, you're not going to get -1/2, you're going to get -0.5. And when you do rad 2 over 2, that's going to be a big, long, ugly decimal. But you'll start getting used to those. If you do want to verify in your calculator, you'll know which ones are the rad 2s over 2 and the rad 3s over 2. All right, so I think you are ready for your Pearson assignment. And again, as always, let me know if you have any questions. Good luck.